Hi guys, in this video we will discuss differential equation. We are going to solve the differential equation which is of the form is x to the power n dn y dxn plus p1 x to the power n minus 1 dn minus y dxn minus 1 plus dot dot plus pn minus 1 x into dy dx plus pny is equal to f of x. So this is a new type of differential equation, and where the power of the independent, and here we see that the dependent variable is y and the independent variable is x, and see here the order of the differential equation and the highest power of the independent variable is same here, and where we consider the function p1 p2 dot pn minus 1 pn all are constant, and this type of equation is known as linear homogeneous differential equation. And our now main objective is to find that how can we solve this type of differential equation. Actually, so to solve this type of differential equation, our main objective is to find that we have to convert the differential equation, that is the form which is given in the format x to the power n dn y dxn plus p1 x to the power n minus 1 dn minus y dxn minus 1 and plus so on plus p1 is equal to f of x. That will be convert to dn y dxn plus p1 dn minus y dxn minus 1 plus p2 dn minus 2 dxn minus 2 plus dot pny is equal to f of x by using the change of the independent variables. So suppose we have to, since we have to change the independent variable, so it must be is of the form that d1y dtn plus p1 dn minus 1y dtn minus 1 plus dot dot plus pny is equal to z of t, and then we have to solve this equation where p1 p2 and pn all are constant. So now let us try to solve one type of problem, that is this type of equation, that is x to the power n dn y dxn plus p1 x to the power n minus 1 dn minus y dxn minus 1 plus p2 x n minus 2 dn minus 2y dxn minus 2 plus dot dot plus pn minus 1 dy dx plus p1 is equal to f of x. This type of equation is known as a Cauchy-Euler homogeneous equation. Cauchy-Euler homogeneous equation. Cauchy-Euler homogeneous equation. So now let us try to solve. Let us take one problem about that what we take, that x square d2y dx2 minus 3x dy dx plus 4y is equal to 2x square. So now see here that here the highest order is 2 and the highest power of the independent variable is 2. So this is a Cauchy-Euler homogeneous equation. Now we have to convert it into a differential equation with constant coefficient. So for changing the independent variable, we take that x is equal to e to the power t, and from here we can write that, from here we can find that dx dt is equal to e to the power t, and then we find that dt dx is equal to 1 by x. I think this is clear to you. So now we can write dy dx is equal to dy dt into dt dx by using the chain rule. So now dy dt is into dt dx, the value of dt dx is 1 by x, and now from here we can write x into dy dx is equal to dy dt. Okay, so now we write that d2y dx2 means d dx of dy dx, and in previous we know that the dy dx means dy dt into 1 by x. So we put the value of dy dx here, d dx of 1 by x dy dt. So now if we find the derivative, we get minus 1 by x square dy dt plus 1 by x square d2y dt2. This is a very simple chain using the chain rule, and so now we can write that the x square d2y dx2 is equal to d2y dt2 minus dy dt. So already see here we change the independent variable x to t. And we just consider here that d square is equivalent to the operator d2 dx2, and theta we consider the operator theta, which is equivalent to d dt, and theta square, the operator is d2 dt2. So now the equation 1 now becomes, that is, first we find the x square d2y is equal to theta square minus theta y, so we put the value theta square minus theta, then minus 3x dy dx, and we find that x dy dx is equal to dy dt. So here minus 3 theta and plus 4 y is equal to 2, and since here that x is equal to, we put e to the power t, so now x square is equal to e to the power 2t, so this will be also changed here to e to the power 2t, and after simplification we get theta square minus 4 theta plus 4y is equal to 2 e to the power 2t. So now this is converted to a simple linear differential equation with constant coefficient. Now we have to find the auxiliary equation. That is, the auxiliary equation is of the form m square minus 4m plus 4 is equal to 0. So the roots are m minus 2 whole square is equal to 0, m is equal to 2. The roots are real and equal. So the complementary function is y is equal to c1 plus c2t into e to the power 2t. So now since this is a non-homogeneous equation, so now we have to find the particular integral also. So from particular integral, this will be 1 by theta minus 2 whole square into 2 e to the power 2t, and from the rules of the by finding when the r of when the right hand side is of the form f of x is equal to e to the power mx, then first we have to put the value of 2 here. So this will be now undefined, so we put here theta plus 2 minus 2, and that is, here we use here that if f of m is equal to 0, then for finding the particular, so now for finding the particular integral here, we use the d operator method, which I discussed earlier in the class. So here for finding the particular integral, this is the form f of dy is equal to r of x, then the particular integral will be y is equal to 1 by f of d into r of x. And see here, since here the function is of the form in t, so whatever, and if this is exponential form, then we have to convert it. We have to put here that 1 by f of m into e to the power mx if f of m not equal to 0. So see here, if you consider this in this equation with this, then what we get, that here I just show here that here the r of t is equal to 2 into e to the power 2t, and by this formula this m is equal to 2, and so if here we put theta is equal to 2, then this will be obsolete term. So now if f of m is equal to 0, if f of m is equal to 0, then we find the particular integral by 1 by f of d plus m into e to the power m. So here now, and since here the function is t, so we just put here theta plus 2 minus 2 whole square 2 e to the power 2t into 1, and so now there is an operation on 2 e to the power 2t, and so now we have to find, so now we have the term is only left here 2 e to the power 2t by theta square into 1, and so now since the operation on exponential function is already done, so here we have to work on the term 1 by theta square into 1, and as we already discussed that 1 by theta square into 1, or in general if theta is an operator, 1 by theta to the power p into f of t, then we have to integrate f of t times, then we have to integrate f of t p times. So now here theta square, that means we have to integrate on 2 times, so if we integrate we get and here the f of t is 1, so if we integrate integration dt, that means integration t, first integration, then after second integration this will be half of t square, and see here, since there isn't 2, so that will be cancelled out, so we get t square into e to the power 2t. And if we first take that e to the power t is equal to x, so we put the value of that e to the power 2t means x square and t square means log x whole square. And so now we can write the general solution is of the form y is equal to c1 plus c2 log x into x square, whereas we first take the complementary function is c1 plus c2t into e to the power 2t, whereas we take e to the power t is equal to x, so we put here t is equal to x, so here we get c1 plus c2 log x into x square plus x square log x whole square. This is the CF plus particular integral, and where c1 and c2 are arbitrary constants. So I think the method is clear. So if you understand the topic, so please like this video. Thank you.